syllabus. If you need any more revision or any topic specifically, you can also tell me. Okay.
Okay, sir.
But for now, I think we should first do that. Some problem solving on collision and vertical circle motion, like work energy power. Okay. So
Okay, sir.
I'll take from your PDF only. Just to get. Mm. So first I take the study package that we have, and I go at the end there. So law of motion is also there in this. Then I think law of motion test already been done. Your work energy, power, and rotational motion. Two chapters coming, right? Okay.
Right, right.
So please go to section A of work energy power, and this is page number 240. Page number 240. Do you have right now?
I select the PDF thing. I'll see the PDF again.
You don't have the hard copy?
No, sir, it's still gone for, I think, the PDF scanning.
Okay. So then go to page number 240 of your, and PDF page number is 245, and the target book page is 240.
Okay, sir. Just 1 second.
Yeah, sure. Question number 6, if you check. A string is used to pull a block of mass m vertically up by distance h at a constant acceleration g by 3. The work done by the tension in the string. Have you found that question, Neil?
Uh, yes, sir. Yes, sir. Found.
Yeah. So there is a string here in which tension is T. The downward force is mg. It is saying that it is being pulled with some acceleration A, and that is equal to g by 3. So and it has gone uh, up to distance h that they have given. It has been moved to a distance h. So work done by tension. First, we need to find what is the tension. As you can see that the body of mass m, upside force is T, downside force is mg, and the body is going upside. So T must be greater than mg. So net force will be T minus mg is equals to mass into acceleration. So T should be mg plus ma, and a in place of a I can use g by 3 that is given there. So T is 3 plus 4, 4 mg by 3. Now let's talk about the work done. What you see that work done by tension. First, we have to find what is the tension and how, in which direction it is acting. Tension is acting upward and the body is also going upward only. So the work done is positive. It is tension multiplied by displacement. So your answer should be 4 mg by 3 times h. So the final answer should be 4 mgh by 3. I think fourth option is correct, Neil. Do you understand this?
Yes, sir.
Do you understand this
Yes,
concept?
sir. Understood. Yes, sir.
Okay.
Understood.
Okay. A similar question on that page is question number 8. That is also a good example of finding work done. It says that a block of mass m is pulled along a circular arc by means of a constant horizontal force F as shown. Work done by this force in pulling the block from A to B. Can you see this question number 8, Neil?
Yes, sir. Yes, sir.
So in question number 8, you can observe we have to find the work done. And force is horizontal, right?
Right. Right.
So displacement also we have to take what displacement we will take, because it is going up also, but we'll take only horizontal component of displacement. Why? Because for always we take displacement along the direction of applied force, then only you can find the work done. Now you can find the displacement from A to B. If I draw here, so if this is A and this is B, this is radius R, this angle is given as 60. I need to find the horizontal distance between B and A. This is the horizontal component. And definitely it is opposite of 60. So I can say it is R sine 60. Remember, I am only trying to find this distance. Why? Because the force is applied horizontally. So the displacement should be also taken in horizontal direction. That is R sine 60. It means work done you can use as F R sine 60 degree, that is root 3 by 2. So you can say it is root 3 FR by 2. Understood?
Yes, sir. Understood.
If you, on the same page, if I take question number 4, question number 4 states that a body constrained to move in z direction is subjected to a force given by F equals to 3I cap minus 10 J cap plus 5K cap. Then what is the work done by this force in moving the body through a distance of 5 meters along z-axis. Have you read this question, Neil? Question number 4.
Yes.
Now,
Yes, sir, I did.
in this, what is the important point here that you can see? It is say, asking that the body is only moving along z-axis, right?
Right.
Because the body is constrained to move along z-axis. So if we'll try to find the work done, so force is formula is force vector dot displacement vector. Force vector is given how much? It is given 3 I cap minus 10 j cap plus 5 k cap. And displacement is only along z axis and it is 5 meter. So can I write 5 k cap? Only 5 k cap.
Uh, yes, yes.
Okay, because it is only along z axis. So ij, there is no displacement. It can also be understood in this way that 3i minus 10j plus 5k, and we have 0 I cap plus 0 j cap and plus 5 k cap. So work done I dot I 3 into 0 is 0. This is also 0. 5 into 5 is 25. So final answer here that you will get is 25 joule. Understood?
Yes, sir. Just one second.
Yeah, sure.
Yes, sir, done.
Okay. Now, in the next space, that is space number 241, one question is based on kinetic energy. That question number I'll take, question number 10. Kinetic energy of a body is increased by 44%. What is the percentage increase in the momentum? First, understand the relation between kinetic energy and momentum. We know that momentum is equals to m into v, and kinetic energy is equal to half mv square. This, if you take a square p square, it becomes here m square v square. Then you take here p square, you divide both sides by 2m, then you get here half mv square. So that means kinetic energy is basically p square by 2m, that is kinetic energy. This is the relation. Now kinetic energy is increased by 44%. Then what is the percentage increase in the momentum? Momentum formula I can find here is under root of 2mk. Understood?
Understood, sir. Yes.
Now new momentum will be under root of 2 times m. Now kinetic energy has increased 44%. If something has increased 44%, it means it becomes 1.44 times. Am I correct, Neil?
Yes, sir.
So 1.44, if you take square root, it becomes 1.2. So 1.2 times of 2 mk, 2 under root 2 mk is p only. So what you find, the new momentum is 1.2 times of initial momentum, and it becomes 1.2 times means zero point 0.2 is the increase and zero point 0.2 is 20%. That means momentum has increased by how much percent? 20%. Second option is correct.
Oh,
Please see if if you have any doubt, then please ask. Okay.
oh,
And similarly, you have to try question number 11. First, you understand this step by step and try to use in this question number 11 for first you try yourself, then I explain. You understood the concept, Neil?
yes, sir.
Now we apply this in the question number 11th. Okay.
Okay, sir. Just one.
Yeah, so
Yes, sir. I'm starting with question number 11.
yeah, please start. First you try, then I explain.
Okay. Yeah, sir. Option 4, I think. 800%.
Momentum of a body is increased by 200%. Then kinetic energy will increase by 800%.
Yes, sir.
Yeah, that looks correct. Good. Now, if variable force is there, one question I'll take. This is question number 13. As you can see that f is a variable, it is 7 minus 2x plus 3x square. So variable force, what do? We integrate f with respect to x, right, Neil? Integration process
Yes,
we
sir.
use, na? Yeah. So here
Yes,
we will
yes.
integrate 7 minus 2x plus 3x square. I am going to integrate, and it is moving from 0 to 5. So I'll get the answer. Just,
Yes.
yeah, just do this calculation. Tell me what answer you are getting. I think 7 will give you 7x, 2x will be give you
Yes.
2x will give you only x square, I think. 2 will be cancelled, and x square will give you x cube. Am I right?
Right, sir. Right, sir.
So 0, if you put everything becomes 0, so only I will put 5. So this is 7 into 5, 35. 5 square is 25, and 5 cube is 125. So 35 minus 25 is 10. So answer is 135.
35.
Okay. Now I want you to go to level 2, Neil. Okay. And
Level 2. Oh,
yeah, assignment that is. And it is page number 266. On the target book, page number is 266. On the PDF, it is 271. That is, I am writing the target book.
no, no, I found it.
Okay, fine.
Which question again, sir?
Second question.
Second question. Oh,
A particle of mass m is projected with speed u at an angle theta with the horizontal from ground. The work done by gravity on it during its upward motion. So if it is a projectile motion, it goes like this. If you see work done by gravity, up to here half part, the work done will be positive. So work done by gravity will be negative because gravity mg is acting downward. But when it returns to the ground, what you find that the work done is to be downward motion, work done will be negative. And it is a cyclic process. It was thrown from the ground and it returns to the ground. So during its upward motion, only if asked on the complete upward plus downward, answer will be 0. But it is only asking Neil upward motion itself, not asking downward. Upward means only going up. So mg is acting downward and it has gone up to height h. So minus mg into h. H formula we know, it is mg. H is projectile motion maximum height reached. It is u square sin square theta divided by 2g. G and G we can cancel. So we get minus m u square sin square theta divided by 2. You understand, Neil?
Yes, sir.
Okay. On the same page, one good question is question number 7. It says that a man is running on a horizontal road, has half the kinetic energy of a body, of half of his mass. When man speeds up by 1 meter per second, then the kinetic energy becomes equal to the kinetic energy of the boy. What is the original speed of the man? It is given that a man is of mass m, let's suppose, and has the half. Its speed is also not given. Let's suppose speed I'll write as v. So definitely its kinetic energy I can say half m v square, and a kinetic energy of half of mass of the person. You take m by 2. A boy, this is a boy only, and its velocity is I say v dash. So its kinetic energy will be 1 half, mass is half m by 2 v dash square. That means actually it is 1 by 4 m v dash square. And it is given that the kinetic energy of the man is half of the kinetic energy of the boy. Okay, k dash. So I can say that k is given as k dash by 2. I can also write here, this is half m v square is equals to 1 by 4 m v dash square divided by 2. This half I am cancelling, m I am cancelling, so I can find that v square is v dash square by 4. It means that v is equal to v dash by 2. Tell me, this is the velocity of the person and v dash is the velocity of the boy. Tell me, up to this you have understood?
Yes, yes.
Now it says that if the man speeds up by 1 meter per second, if the man speed is now v plus 1, then its kinetic energy will be half m v plus 1 square, and then it becomes exactly equal to the kinetic energy of the boy, that is 1 by 4 m v dash square. So I have to find the value of v, that is the speed of the man. So you can see that first m you can cancel here. 1 half also you can cancel here in terms of 2. So what you see that v plus 1 square is equal to v dash square by 2. I have, in place of v dash, I can use 2v. You can see in place of here by this equation, in place of v dash, I can use 2v. So that is 2v square by 2. That is 4 divided by 2 is 2 times of v, 2v square. So I have equation now, v plus 1 square is equal to 2v square. If you square root both sides, then v plus 1 is equal to root 2v. It means that I can take v that side. So 1 is equal to v, I can take common, that is root 2 minus 1. So my answer v of speed is coming 1 by root 2 minus 1. And if you rationalize this root 2 plus 1 by root 2 plus 1, so denominator becomes 1 only and numerator becomes root 2 plus 1. That is the answer. So this was a good question. You please go through it and tell me whether you understood this or not.
Okay, sir. Yes, sir. Done.
Okay. Now I want you to solve few question vertical circular motion. That is, I can see question number 26.
26 of level 2 only, right?
Yes, yes, level 2 only.
Okay, sure, sir. Sure, sir.
So it's shown that 26 is in the figure shown a particle is released from the position A on a smooth track. When the particle reaches at B, then the normal reaction on it by the track. And the track looks like it is some arc first here, and then it is some circle like this. Oh, not like this. If I say the circle here is completed, the body complete the circular track, let's suppose. So what you think if the particle is moving like this here, first it has come from some height. This is the ground, you can see here, and it has moved here and then it goes inside and it is here. Okay, it is here. So this part is not there. So at this point, they're asking what is the normal reaction. This part has a radius equal to h, and this part has 3h. First of all, we can conserve the energy because based on energy, at this point, it is having potential energy nil, and
Yes.
at this point B, it has a potential also and some kinetic energy also. So if I conserve between this point and this point, then I can say initial energy is here mg into 3h, and here the energy will be this, as the radius is h, so it means that this complete is diameter, that will be 2h, this will be 2h. So here I can write mg into 2h plus some kinetic energy that we don't know at this place, at this point, what is the velocity that we don't know. So I write half mv square. I'm cancelling 3gh minus 2gh is gh only. So gh is equals to v square by 2. It means that v is equals to under root 2gh. That is the velocity. Now they're asking the normal force. So for normal force, we know that it has mg force downward. It has the normal force also towards the center because this is the surface here, and both will provide the centripetal force. That means centripetal force, that is force towards the center, will be the sum of mg and n. And centripetal force formula is basically mv square by r. That means the normal reaction will be mv square by r. R is here h, so I can use mv square by h minus mg. V square will be 2gh, as you can see here. So it is m into 2gh divided by h minus mg. H has cancelled, 2mg minus mg. My answer is coming mg. That will be the normal force at the B. Normal force at B should be mg. Please understand this question step by step, Neil.
Yes, sir. Sure. Yes, sir. Understood.
Okay. Now, one question is question number 29. It is based on inclined plane and conservation of energy on the same page 29. A block of mass under root 2 kg is released from the top of an inclined smooth surface as shown in the figure. If the spring constant of the spring is 100 Newton per meter and the block comes to rest after compressing the spring by 1 meter, then the distance traveled by the block before it comes to rest. We have been given a here right angle triangle, and here we have the spring that is connected, and a block of mass under root kg is released from the top of a inclined smooth surface. Spring constant is 100 Newton per meter. And the block comes to rest after compressing the spring by 1 meter. Okay, let's suppose the block comes up to this much distance and then it stops. So this I think is given as 1 meter. The that only na yeah, is compression in the spring is given 1 meter, and then the block comes to rest. Where it comes to rest, at that I'll take as the reference line. The angle is given as 45 meter. Let's suppose it has traveled some distance x. So total distance is x plus 1, as I can see, because 1 meter is the compression also. You can also find the complete x here. That is also not a problem. Okay, that also we can do. Now, I want to know that how much height it has come down. This height I want to know. So as the angle is 45, so I can take is cos 45, sin 45, both I can take. So length, I can see the distance travel is x plus 1. You can take sin 45, sin 45 degree. So it looks like it is x plus 1 divided by root 2. That is that much height it has come down. And as there is no kinetic energy because the block has finally stopped, so whatever energy is there is only potential energy of the spring, and potential energy of the spring formula is half kx squared. So if the any particle comes down, it loses the potential energy. So I can say loss of potential energy of block. Okay. And or you can directly use the conservation law also, that what is the initial energy and what is the final energy, because surface is smooth. So initial energy is mgh, and final energy is half k x. X is also not, it is given 1. So half k 1 square, because 1 meter is the compression in the spring. M is given under root 2. G you can take as 10. Height is x plus 1 divided by root 2. And this side k is given as 100, and compression is 1 only. Root 2 cancel. This 2 I can cancel as 50. This 10 I cancel as 5. So I find x plus 1 is equals to 5. And my answer is not x. My answer is x plus 1 only, because it is asking the total distance traveled before it comes to rest. So x is this much, and then again it moves by 1 only. So my answer is x plus 1 is equal to 5. So 5 is the final answer. Please check it, Neil. If you have understood any doubt, please ask.
Yes, sir. I'm trying. One second.
Okay.
Yes, sir. Understood.
Okay. Now let's do few questions on collision, Neil. On the level 2 only, I'll take question number 41 on collision. Okay.
Okay.
A ball is dropped from height h on a horizontal floor. If it loses 60% of its energy on hitting the floor, then the height which it will rise after the first rebounds. It is given that a particle has been dropped from some height h on this ground. And after rebouncing, when it strikes the ground, this is ground only, and this height is given as h. So definitely it was having how much energy here? Potential energy was mgh. While going, it is given that it loses how much percent? 60% energy is lost. So how much is the remaining, Neil? 40%, right?
Yes. Yes.
So now the energy it is having, it is only 40%. 40% or 40 by 100 is m, sorry, multiplied by initial energy mgh. As we know that m and g are constant only, so it will only go 40% of the height, because energy is proportional to h only. So if energy is 40%, so the new height that it will go, it will be only that h dash will be only 40% of 40% of the actual height. Do you understand, Neil?
Yes, sir.
So that
Understood.
means 20 to 25. That means new height is 2h by 5. That should be the answer. Right?
Right. Right.
Understood the concept?
Yes, sir.
Okay.
Yes, sir, done.
Okay. So one more question I'll take on the collision only. I'll take question number 43. A ball is dropped on a horizontal surface from a height h. I'll tell you first concept here. If a body is dropped from some height h, then after and this is the speed of striking the ground, let's suppose initial speed is given as v. Then after first rebound it is speed, that is v1, is actually e times of the actual speed, that is v, where e is the coefficient of restitution. If it goes second rebound, then second rebound will be again e times, it becomes e square v. If it rebounds third time, then again e times, it becomes, that is I can write that the speed after third rebound is e cube into actual speed. Similarly, if I say what will be the velocity after nth rebound, so it is basically e to the power n into v. So remember is this as a formula. Okay.
Yes, yes.
Also, if I say a particle is dropped from height h, so after first rebound, how much height it will go? It is proportional to e square times of actual height. In the second rebound, how much it will go? That is h2. It will be e to the power 4 into actual height. Third rebound, how much it will go? It will be e to the power 6, e to the power 6 times h. And similarly, in nth rebound, how much it will go? It is e to the power 2 times of n. I'll write again here. H n is e to the power 2n times of h. So this two formula you should remember before attempting this question. It says that it rebounds after up to height h by 2 after first collision. First collision means rebound height means this concept I can use. First is h1 is equal to e2 into h. And this h1 is given, the height is given as h by 2. In the question it is given h by 2 is equal to e square into h. H you can cancel. So what you find here that e square is 1 by 2. It gives you the value of e, that is 1 by root 2. I think in 43, first option should be correct.
Yes, sir.
This you copied?
No, sir, I have to copy it.
Okay, okay, please copy.
Yes, sir. Done.
Okay. We'll take question 47. First, I want you to try this. It is example of perfectly inelastic collision that we have studied. First, you try, then I explain. Velocity of the ball A after collision with the ball B as shown in the figure. What will the velocity of A after the collision? The collision is perfectly inelastic.
Okay, sir. Sorry. Yes, sir. The answer will be fourth option, 0.
Yes, very good. Because it is opposite sign, so negative you have to take, na? 10 minus 10, that is 0. One question also we have done na, such question in the class.
Yes, sir. Perfect elastic.
Yeah, perfectly last. So, do you feel confident about tomorrow's exam, Neil?
Yes, sir. I feel confident now that I'm able to solve.
Okay, fine. You revise all the formulas thoroughly and you write the test, and after test you update me, okay?
Okay, sir. Sure. Sure.
All the best.
Thank you, sir.